Okay, let's move on. So the next problem asks us to factor 7a squared plus 53a plus 28. So with this one, start again by looking at your a value. Our a value is 7, and the factors of 7 are just 1 and 7. So that one's nice and easy for you again. But when we multiply a times c, we're going to get a number that's not as pretty as we're used to working with. So a times c is going to be 7 times 28. And I don't know that off the top of my head. So 28 times 7, 7 times 8 is 56. Bring up the 5. 7 times 2 is 14, plus 5 is 19. So 196 is what we're looking at. So we're going to need to find two numbers that add to 53 and multiply to 196. So we're going to have our work cut out finding factors, all the factors of 196. Okay, so factors of 196. 1 and 196. 2 and 98. 4 and 49. 5 doesn't work. 6 doesn't work. 7 and 28. And all I'm doing is division. So if you can see my paper, I'm just working my way down through the numbers and figuring out by long division what works and what doesn't work. I hate using calculators in situations like this because I just feel like understanding what numbers are divisible by what is just a huge part of factoring, and it's just great practice. So I recommend going the long way. 9 does not work. 10 doesn't work. The last one I think is going to work is going to be 14 and 14. So now we have all the factors of 196. And we need to figure out which two will give us the sum of 53, because we're looking for that b value of 53, positive 53. So 1 plus 196 is just going to be 197. 2 plus 98 is going to be 100. 4 plus 49 is going to be 53. 7 plus 28 is going to be 35. 14 plus 14 is 28. Now we're looking for two numbers that multiply to 196, which is all these, and add to 53. So that would be this guy and this pair right here. And again, it's important to remember, don't just write x plus 4, x plus 49 and think you're done. Our a value is greater than 1, so we have to plug it into the original equation and do grouping. So here we'll have 7a squared plus 4a plus 49a plus 28, which is our c value. And again, these numbers should add up to your b value. If not, you got something going on that's wrong. So let's factor. I can factor an a out of here, and I'm left with 7a plus 4. And it looks like I can factor a 7 out of here, which is going to leave me with 7a plus 4. Okay, now that we've done that, I see that there's a 7a plus 4 over here, and a 7a plus 4 over here, so we can factor that out. It's going to give us a 7a plus 4 on one side, and what we have left over is an a plus 7. A plus 7. And now to make sure that that works and is correct, let's use the FOIL method and multiply it out. 7a times a is going to be 7a squared. So that's first outside. 7a times 7 is going to be 49a. Inside is going to be plus 4 times a is 4a. And 4 times 7 for the last is going to be 28. We'll combine our like terms. This is 7a squared still. These combine to get 53a. And the 28 just comes straight down. This is the same as our initial problem, which checks. We can then rewrite our answer as 7a plus 4 and a plus 7, box it, and that's it. So the last problem we're looking at today asks you to factor negative 6a squared minus 25a minus 25. And I want you to look at this question really carefully, or this problem very carefully, because if you see something here, it'll save you a lot of grief in the future. So what I see is that there's a negative here, 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 which means that all of these guys could be multiplied by -1 if they were positive to give us this same result. So what I'm going to do is I'm going to pull out my -1, and then here I'm going to have 6a squared plus 25a plus 25. And now, since we have positives here, it's going to make my life a lot more easier. But I do need to remember then that my answer, my final answer, is going to look something in the forms of -1 times some a value plus or minus some other value, and another a value plus or minus some given value. So I just need to remember to put my -1 here whenever I'm done. So that's why I put that down like that. So let's just look at it in terms of this problem here, which is 6a squared plus 25a plus 25. Our a value is 6. So we have factors of 1 and 6, as well as 2 and 3. And this is the first time that we've had more than one possible set of factors. But thankfully, because of the grouping method, it won't matter which set that we choose, we'll still get to the correct answer. So our next step is going to be multiply our a and c value, and remember, we're starting from here now. Don't worry about this anymore. We did the preliminary stuff over here, and now we're simply working from here down. So our a value is going to be 6 times 25, which should be 150. A times c equals 6 times 25, which is equal to 150. And now we just need to do the problem in the way that we've been doing these problems. So factors 150, and And we're going to start with 1 and 150, 2 and 75, 3 and 50, 4 doesn't work, 5 and 30, 6 and 25, 10 times 15. I believe that is all. So since it's positive 150, we don't have to worry about looking for the negatives, but we need to find a sum of 25. Because our b value here, remember we're looking here, not over here, our b value is positive 25. So let's look for the sums. I guess we don't have to look for them, let's calculate them. So 1 plus 150 is 151, 2 plus 75 is 77, 3 plus 50 is 53, 30 plus 5 is 35, 6 plus 25 is 31, 10 plus 15 is 25. And 25 is what we were looking for because it's a number that multiplies to 150, which is what we needed, and adds to 25, which is also what we needed. Okay, I'll say it again, just so you don't make the mistake. Don't just put x plus 10, x plus 15 here. It will not be correct. We have to plug it back in to our problem here, because this is what we're working on. We're almost pretending that this whole beginning part didn't really happen. All we're solving is this guy. So we'll have our 6a squared plus 10x plus 15x plus 25, which is just our c value. Break it up into groups, which is why we call it grouping. And as you can see, I made a mistake here because I copied these down as x's. These should be a's because if I leave them as x's, you can't factor an a out of an x. It's like trying to take an apple out of an orange. It doesn't work. So make sure you write your coefficients correctly. And so that's an a and that's an a. I apologize if it's unclear. So we have a squared and 6a squared and 10a, so we can factor out, let's see, a 2a, and we'll get, let's see here, 3a plus 5. And over here we can factor out a 5, so we'll get 3a plus 5 again. And as we've been doing before, since there's a 3a plus 5 here and a 3a plus 5 here, we can factor it out, giving us 3a plus 5 over here. And what's left over is a 2a plus 5 and those should be the factors for this problem up here. But remember, we're not done. We always have to go back to this part because we factored out a -1 here. So I want my answer to look something like this. So I'm going to have a -1 times 3a plus 5 2a plus 5. And I can box that off.